matrix methods of structural analysis. Before that, since this is the first lecture, let me introduce myself. I am Dr. Perumal, a retired professor from government engineering colleges. Recently, I have joined in this PhD Institute of Technology and Applied Research. I thank the respected management, respected principal, respected vice principal, and all officials for having given me an opportunity to work in this prestigious institution after my retirement. And the motive of the lecture is I wish the video to be useful for our students, that is you all, and in general to the community. So that is the motive of this lecture. I have referred so many books, of which myself along with my senior author come guide have also published a book on structural analysis. So structural analysis volume 1, volume 2, and one more short questions and answers in structural analysis. That's a brief introduction. Then coming to the topic, today we will take up the topic on matrix methods of structural analysis. Today we will have the introduction. Lecture number 1 covers only introduction to the topic. Now, a structure may be a bridge, may be a building, may be a chimney, whatever may be. Structure is subjected to some system of loading. The structure will receive the load from some point and transmit it to some other point. For example, we take a building, the load will be applied to various floors. Floors will transfer the load to the beams. Beams will transfer the load to the columns, and then to the foundation, and then to the soil. So the function of the structure is to transmit the load from one point to the other point. The structure may be, but there are two types. One is skeletal structures, the other one is a continuum. Skeletal structures will be consisting of individual members, namely, suppose you take a building frame, it will be consisting of beams, columns, slab, foundation, etc. Suppose if we take a roof truss, it will be consisting of an assembly of tension and compression members. So they are called skeletal structures. Suppose we take a continuum, the slab is a continuum, having a continuous surface. A shell is a continuum, cooling tower and all those things are having continuous surface. These are the two types of structures in general. Now, a structural analyst has to analyze the structure and find out the internal forces and also the displacement, because during the process of load transfer, the members will be subjected to bending moment and shear force, and also displacements. So bending moments, generally bending moments are designed, shear force and also the twisting moment will be useful for the design of the structure. Displacements normally will be checked. The deflection will have to be within so much, like that it is given. So once the analysis is over, namely bending moment, shear force is over, the respective code books will guide you how to design. Suppose if we take RCC, IS 456-2000 will guide you. It consists of lot of formulas, tables, descriptions, etc., giving the design guidelines. How to design the cross section, how to find out the reinforcement, that is guided by IS 456. Suppose you want to design a steel structure, it is again guided by IS 800-2007. Pre-stressed concrete, IS 1343. So like that, for every material, for RCC, timber, masonry, everything, we have got a separate code book. So that it is the duty of the analyst, structural analyst, to find out the bending moment and shear force. So for that, one must have a knowledge about how the load get transferred to the structure, whether the load is acting as a point load or UDL or uniformly varying load, one has to be familiar. Then, when it is subjected to loading, how the structure behaves, whether the structure is going to behave as a cantilever, a simply supported beam or slab, a continuous beam or slab, so that one must be familiar. So after knowing the loading pattern and after knowing the behavior of the structure, that is very important. So we can find out the internal forces and also the displacements. Why we have to find out the displacements? So displacement also the code book gives you for a cantilever. So suppose if it is RCC structure, what is the maximum permissible deflection? If it is a simply support beam, maybe RCC or maybe steel, what is the maximum permissible deflection? Because deflection is very important, because when the deflection goes beyond certain limit, suppose this beam undergoes a deflection of some 100 mm sagging, we will not be comfortable to sit, we will not even enter the class. After seeing the deflected shape, we will not be able to feel comfortable to sit inside the hall. So deflection and also the finishing works, plastering, painting, all these will get peeled off. Therefore, deflection is also important. So in an elastic structure, there are two important interrelated quantities, namely forces and displacements. If the force displacement of a structure is known, then the behavior of the structure is known. Now, coming to the analysis, we have studied a number of methods already, like slope deflection method, moment distribution method, strain energy method, etc. But those methods are meant for structures with less number of static and kinematic indeterminacy. So when the indeterminacy is beyond certain limit, it will be difficult to analyze. For example, if we take slope deflection method, if there are, so we will just start from the kinematic indeterminacy, kinematic or the number of possible joint displacements. Suppose the number of unknowns are 3, namely theta A, theta B, theta C, because in slope deflection method, slopes and deflections are unknowns. Suppose there is no deflection, there are 3 unknowns, theta A, theta B and theta C. Now you have to form equations, and for getting theta A, theta B, theta C, as you know, we have to solve 3 equations. For getting 3 unknowns, you have to form and solve 3 equations. Suppose there is one more unknown, you have to solve 4 by 4 unknowns. 4 by 4 unknowns, manually solving, how difficult, you know. It's very difficult. Therefore, whether moment distribution method or slope deflection method or any other classical method will be convenient only up to certain degrees of indeterminacy. Right. Now this matrix methods is meant for multi-storied buildings and complex structures. These are all not meant for 2-span beam or 3-span beam. Why we are studying this? So we must learn the procedure. Actually, when you use softwares on flexibility method or stiffness method, how you have to input the data, how it is being solved inside, what is the data, how to interpret the data, in what order you have to take the values, all these things you will understand. And also you can write a program if you know the procedure thoroughly. Therefore, this method is not meant for 2-span or 3-span beams, but still it is a must to know what is happening inside the computer when you use a particular software. Therefore, that is a need for the method. Right. Now here there are 2 methods. One is matrix flexibility method, the other one is matrix stiffness method. matrix stiffness method. Matrix flexibility method, here we are treating the forces as unknowns. Forces are unknowns. Here in stiffness method, displacements are the primary unknowns. Therefore, matrix flexibility method is also called force method. Force method because forces are treated as the unknowns. Also, we follow the principle of superposition of forces. The method starts with principle of superposition of forces. So forces are unknowns. Therefore, the method is otherwise called as the force method. Also, it is called as compatibility method. Compatibility, also it is called. So it ends with the compatibility equation. So I will explain those things later. So the other names for, because sometimes you will be expected to explain why the flexibility method is also called as force method. Why the flexibility method is called as also the compatibility method. What are the other names given for the flexibility method? Those things will be normal, so we must know. Similarly, coming to stiffness method, it is otherwise called as displacement method. Displacement method or equilibrium method. The equilibrium method. Because here displacements are the primary unknowns, so it is called displacement method. Also, the method will start with the principle of superposition of displacements. So what is principle of superposition of forces and displacements we will discuss subsequently. That's about the methods. So here we will end up with the equilibrium equation. The method uses equilibrium equation, therefore it is called equilibrium method. Now let us first concentrate on flexibility method. Flexibility method. Flexibility matrix method. The basic equation is A into F equal to U. A into F equal to U. In some books they will mention A into F plus U equal to 0 or A into F equal to minus U. This is also correct. You can write it like this or write it like this, no problem. That is not a problem. But after seeing this compatibility equation, you need not get confused. So this is also correct. A into F equal to U. That is the compatibility equation that is adopted in matrix flexibility method. Now this is the flexibility matrix. This is the flexibility matrix. This is force vector. This is force vector. This is displacement vector. Displacement vector. Now, when you form the flexibility matrix or displacement vector or force vector, we use what is known as coordinates. Let us take a simple example of a cantilever. Let us say this is coordinate number 1. This is coordinate number 2. This is coordinate number 3. This is coordinate number 4. Coordinates are points and directions in which a measurement is desired. It may be measurement of a force or it may be measurement of a displacement. Right. Now, one means, so along this direction, you may be interested in applying a force and you want to measure the displacement. This is the displacement. Or you may be interested in applying a known displacement along this direction, apply a known displacement and find out what is the force causing that displacement, force and displacements. Right. So similarly, coordinate number 2, you may be interested in applying a moment, find out the corresponding rotation, or you may be interested in applying a known displacement, find out what is the force corresponding to that. So that is about the coordinates. Coordinates are arbitrary. You can increase the number of coordinates, you can decrease the number of coordinates as far as you can statically determinate structure is concerned. So the size of the flexibility matrix will be equal to the number of coordinates. So here we have marked 4 coordinates. So the size of the flexibility matrix will be 4 by 4. So next lecture we will discuss about how to generate the flexibility matrix for determinate structures. So the size of the matrix will be 4 by 4. Right. After knowing that, now coming to force vector we will have F1, F2, F3, F4. So we are following what is known as generalized forces and generalized displacements. So one, the force or displacement must be independently applicable. Number 2, F1 will be a vertical force, F2 is a moment, F3 is a vertical force, F4 is a moment. So you must know what is the order in which we give the coordinates. So this force vector will be consisting of transverse forces, axial forces, bending moments, twisting moments. It can be any combination depending upon what type of forces to which the structure is subjected to. It will be containing forces and moments and also torques. Similarly, so here that is the point. Now coming to displacement, U1, U2, U3, U4. Now here again, generalized displacements. The displacement may be transverse, translation, axial displacement, moment or rotation, corresponding force is rotation, displacement, rotation and also twist. It can be anything. Now in this case, U1 is a vertical displacement, U2 is a rotational displacement, rotation, U3 is again a vertical displacement, U4 is again rotation. It can be displacement, rotation and also twist, anything. That is what is called a generalized forces and generalized displacements. So we must know the coordinate system. Right. Now next one, what is flexibility matrix? Now flexibility matrix A will be consisting of A11, A12, A1n, A21, A22 up to A2n, where n stands for the number of coordinates, AN1, AN2 up to ANn. This is the flexibility matrix consisting of flexibility coefficients. So these are all called coefficients. A in general you can say Aij. Aij is the flexibility coefficient. Aij gives the displacement at coordinate I due to unit force at coordinate j. The same cantilever, suppose we consider you apply a force moment etc. Now you first apply unit force along coordinate 1, unit force. Now if you measure the rotation here, or displacement here, the displacement here is A, the displacement at coordinate 3 due to unit force at coordinate 1. Here this is the rotation, the displacement measured along coordinate 4 due to unit force at 1. So for getting the 4 by 4 matrix, we have to apply unit force along coordinate 1, measure the displacement here, that will be the displacement along coordinate 1 due to unit force along coordinate 2. Now if you measure the rotation here is displacement along coordinate 2 due to unit force at 2. You have applied unit force only one at a time, namely along coordinate number 1. So you have to form the first column of the flexibility matrix, that is the flexibility matrix. The first column is A11, A21, A31, A41. That is by applying unit force along coordinate 1 only. Then applying unit force along coordinate 2 only, you will get a deflected shape. Again measure the displacement. This is a displacement along coordinate 1 due to unit force along coordinate 2. The rotation here is the value of A along coordinate 2 due to unit force along coordinate 2. Here this displacement is a displacement along coordinate 3 due to unit force along coordinate 2. The rotation here is the displacement along coordinate 4 due to unit force along coordinate 2. So that will give you the second column, A, the displacement along coordinate 1 due to unit force along coordinate 2, similarly 2 to A3 to A4 to. Similarly, you will have to form all the 4 columns. You apply. So that is, now if you see the definition, flexibility coefficient is defined as the displacement at coordinate I due to unit force along coordinate j, that is Aij in general. So a flexibility matrix will be consisting of flexibility coefficients. So for statically determinate structures, you can form like this. The size of the matrix will be equal to the degree, the number of coordinates. In the case of statically indeterminate structures like continuous beams, portal frames or redundant trusses, etc., it will be equal to the degree of static indeterminacy. So the degree of static indeterminacy is very important in the case of matrix flexibility method. The size of the matrix, the flexibility matrix will be equal to the degree of static indeterminacy as far as the statically indeterminate structures are concerned. For statically determinate structures, that will be equal to the number of coordinates that we assign. And one more point, namely when you find out these displacements, these are all displacements. This is the displacement along coordinate 3 due to unit force along coordinate 2, that's over. Now, there are 4 forces, 1, 2, 3 and 4. So we apply unit force along coordinate 1 only first. Then you apply unit force along coordinate 2 next. Then along 3, along 4, form the third column and fourth column. So for linear elastic structures, the effect of applying a number of forces simultaneously, applying 1, 2, 3, 4, find out the effect. So for example, suppose if you want to find out the displacement here due to all these 4 loads will be equal to, apply the force here, find out the displacement here. Apply the force along coordinate 2, find out the displacement. Similarly 3, find out the displacement. 4, find out the displacement. The sum of all these 4 displacements will be equal to this value. By applying all the forces simultaneously and getting a displacement at a particular coordinate, you can get the same by applying the forces individually, adding all the displacements. That is, suppose this is A will be equal to A11 plus A12 plus A13 plus A14. So that is what is called principle of superposition of forces. That is also one reason why this method is called as the force method. So that is about superposition of forces, and that is the definition for flexibility coefficients. Then what is coordinates? Coordinates, as we discussed, coordinates are points and directions in which a measurement is desired. And then as far as matrix flexibility method is concerned, when you analyze a statically indeterminate structure, you have another term called primary structure. You got a term called primary structure. Now primary structure is a statically determinate structure. So whatever may be the structure, find out the degree of indeterminacy. The first step is find out the degree of static indeterminacy of the structure and identify the determinate structure by removing as many number of forces as required for making the structure statically determinate. Now let me take a simple example. That is, we want to analyze, say, a propped cantilever. Simplest example we will take. We want to take analyze a propped cantilever. Now, a propped cantilever is statically indeterminate to 1 degree. Because by removing the support, it will become a cantilever which is a statically determinate structure. Now, this is the given structure. Given structure. We have to make the structure as a primary structure or statically determinate structure. Now, what we do is, you can just remove the right support and make the structure as a primary structure. This is a primary structure. That is, you have removed the support at B. This is AB. Removed the support at B. So that means you have treated this RB as redundant. RB, you have treated as redundant, removed RB, and the structure is now determined. This is one way of making the structure as a primary structure or statically determinate structure. Because the static indeterminacy is 1, you have to remove any one internal force, any force or reaction, so that the structure will become determinate. Or the same structure, you can retain the support at B. This is a fixed end. Now introduce a hinge here. That is, you are treating the moment at A, MA as redundant, and you are removing. That is, by introducing a hinge, this support cannot take any moment. Or in other words, you are treating MA as redundant, removing it by the introduction of one hinge. Now the structure will behave as a simply supported beam. A simply supported beam is a statically determinate structure. So this is also a primary. So the first step is finding out the degree of static indeterminacy and make the structure as a primary structure by removing as many redundants as required. Because the static indeterminacy is 1, means you have to remove one redundant so that the structure will become determinate. So this term is another important term in matrix flexibility method. Then in finding out the deflection, so you have to recall whatever you have studied earlier in the mechanics of solids 1 or strength of materials, whatever you have studied. So you have to find out the deflection, A11. So you want to apply, this is a structure, you want to apply some force here. Then you want to find out the deflection. What is the deflection here? What is the deflection here? What is the rotation here? For all these things, you will have to follow any of the method that you have studied earlier. Mostly, we will be using moment area method and conjugate beam method. So, conjugate beam method and moment area method, you will have to recall that basics are necessary here. So, that is about the necessity of the methods of determination of the deflection. So, like this, some fundamentals will be needed. Also, in the analysis, you will be, suppose you want to analyze a continuous beam, you must know something about the fixed end moments. In the 4th semester, you have studied fixed beams and continuous beams. So, finding out the fixed end moment for the given span and loading is a full problem in your strength of materials 2. Now it becomes a fundamental. Suppose if you are given a fixed beam, you are asked to analyze a continuous beam. You are given with UDL over the entire span and the non-central load AB, WAB. This is W per meter run. So you know M of AB is minus WL square by 12. Here it is minus WL square by 12. Here it is plus WL square by 12. Coming to the span BC, for when it is subjected to non-central load, you know M of BC is minus WAB square by L square, and M of this value is M of CB is equal to WA square B by L square. So these formulas you will have to recall. So all the fundamentals are, so if you are thorough with the basics, strength of materials, you will find a lot of comforts in doing problems on matrix methods. Matrix methods will be containing number of steps, but still you can solve it easily if you know the basics. Whatever studied your strength of materials 1 and 2 will be very much essential. So that is a very brief introduction about the basics and also what are the fundamentals that are required from what you have studied earlier as far as matrix flexibility method is concerned. And also you must be familiar with that of matrix operations, matrix multiplication, matrix addition, and all the matrix inverse and all. If you know all those things, it is only an application problem. Now here you will be following what is known as, you will be getting a transformation matrix. Transformation matrix we will discuss when we discuss about the procedure. I don't want to cover everything here because it is only introduction. Next is that of stiffness method. In the stiffness method, the equilibrium equation is K into U equal to F. K into U equal to F. K is the stiffness matrix. Stiffness matrix. U is the vector of displacements or displacement vector. Displacement vector. This is force vector. Force vector. Now here these are the unknowns. Displacements are the unknowns, or you can say primary unknowns. Ultimately we will find out the forces. Ultimately we will find out the values of MAB, MBA, etc. But primary unknowns are the displacements. So that is why this method is otherwise called as the displacement method. Displacement method. Right. Now, and already we have got introduction about force vector and displacement vector, which need not require any repetition. Coming to the stiffness matrix K. K equal to K11, K12 up to K1n. K1n, K21, K22 up to K2n, up to Kn1, Kn2 up to Knn. These are the right. Any value you take, so you take some value Kij, any value, in between value. Now Kij is the stiffness coefficient. Kij is the stiffness coefficient. A stiffness coefficient is defined as a coefficient which gives you the force at coordinate I, due to unit displacement at coordinate j. Force at coordinate I due to unit displacement coordinate j, with the condition that no displacement occurs except at j. That means, for example, so again let us take a cantilever with only two coordinates, so coordinate 1 and coordinate 2. Now apply unit displacement at coordinate, find out the force at the coordinate j. That is, first apply the displacement at coordinate I, coordinate 1. Coordinate 1 means you have to apply unit displacement only along coordinate 1 and not along coordinate 2. That means now this end will undergo, when you apply unit force at along coordinate 1, there will be displacement along coordinate 1 as well as 2. Rotation will be there, displacement will also be there. Now here we are applying unit displacement. So when you apply unit displacement along coordinate 1, you should not apply unit displacement along coordinate 2. So that is why, so I mean, so that you apply displacement along coordinate 1, so this end should not undergo any rotation. It has to undergo only displacement along coordinate 1. Should not undergo any rotation. That means you are going to treat this as a fixed end. That means a fixed end will not have any rotation. So you have to treat this, apply only unit displacement along coordinate number 1. Then second one, you apply unit displacement only along coordinate 2. Only along coordinate 2 means you apply rotation. So apply unit rotation, and you should not allow any displacement here. Therefore, this will be treated as supported. So even though it is a cantilever, when you apply the displacements, you have to be careful. You apply only vertical displacement. Here apply only rotation and find out the forces. So here there are two coordinates. Two coordinates will be, the matrix will be, K will be K11, K12, K21, K22. Because there are two coordinates only. Therefore, the size of the stiffness matrix will be 2 by 2. So that is why I will repeat the definition. Kij stands for the force developed along coordinate I due to unit displacement along coordinate j, with the condition that no displacement occurs except at coordinate j. So vertical means only vertical displacement, no rotation. Rotation means rotation only, no vertical displacement. So accordingly you have to treat the far end as fixed or hinged, and then you have to find out the force. These values are forces. K11, K12 are the forces. Now for this again whatever you have studied in moment distribution method, an idea will be required. That is, when there is a settlement of support, here, unity, then the moment developed at the supports will be, already we have studied, 6EI delta by L square, 6EI delta by L square, and of course delta equal to unity, therefore it is 6EI by L square. This will also be 6EI by L square. This is when the right support settles down by unity. Similarly, when the left support settles down by unity, both moments will be clockwise. That is fundamental, which you have studied already. So your knowledge of these things you have to possess, and you must be able to recall these things for finding out the forces. And when these are subjected to moments, when you find out the reactions, this is anti-clockwise, this is anti-clockwise, therefore this reaction will be clockwise, this reaction will be upward, this reaction will be upwards, the values will be 12 EI by L cube. This is also 12 EI by L cube. Therefore, in this, the K matrix, K11 is the force developed along coordinate 1 due to unit force along coordinate, unit displacement along coordinate number 1 is 12 EI by L cube. 12 EI by L cube. The force developed along coordinate 2 due to unit displacement along 1 is anti-clockwise. So 6 EI by L square anti-clockwise. Therefore, it is minus 6 EI by L square. Minus 6 EI by L square. Because this is clockwise, this is anti-clockwise. Right. Now coming to this problem, we have studied the moment distribution method that the moment required at the nearer end for causing unit rotation when the far end is fixed is given by 4 EI by L. When far end is fixed, it is 4 EI by L. When far end is hinged, it is 3 EI by L. Right. When this is the case, then there will be a carryover moment to the opposite end. Carryover moment to the opposite end is 2 EI by L. 2 EI by L. This is the basic proposition in the moment distribution method. So you have to recall all those things. All those things will form this method, right? Now, so this is clockwise, this is clockwise. When you find out the reaction, this is clockwise. So the reaction here will be downwards. The reaction here will be upward. By taking moment about one end, you can find out the reactions. So basics. So this reaction will be 6 EI by L square. This reaction will also be, by taking moment about the right support, left support, you can easily find out. So that's about the forces. This is due to the rotation. Right. Now, second column, K12. K12 is the force along coordinate 1 due to unit force along coordinate 2. That is equal to 6 EI by L square. Now here the force is downwards, the reaction is upwards, therefore minus 6 EI by L square, and this is clockwise. The moment here is also clockwise. The moment is 4 EI by. So this is the stiffness matrix for the given problem. So again, you are expected to be strong in the fundamentals. So that's about the stiffness matrix and also the equilibrium method. So this is sufficient for introduction part. We are going to discuss everything elaborately. Right. Now, here you have followed the superposition of displacements. You have applied displacement along coordinate 1 only, displacement along coordinate 2 only. So you apply one displacement at a time, and so this is also applicable only for linear and elastic structures. So that is why this method is called a displacement method. So we are basically forces are unknowns, and also we are following superposition of displacements. And we have discussed the stiffness coefficients. Unknowns are the forces, the primary unknowns are the displacements here. Now here kinematic indeterminacy. So for statically determinate structures, the size of the stiffness matrix will be equal to the number of coordinates as before. For statically indeterminate structures, here we are using kinematic indeterminacy. Therefore, the size of the stiffness matrix will be equal to the degree of kinematic indeterminacy, number of possible joint displacements, as we have followed in the slope deflection method, theta A, theta B, theta C, delta. What are the possible joint displacements? So that will decide the kinematic indeterminacy, stiffness matrix in the case of statically indeterminate structures. For statically kinematically indeterminate structures, that is based on the number of coordinates. Now, suppose we take a fixed beam. A fixed beam is a kinematically determinate structure, statically indeterminate, but kinematically indeterminate, means determinate, because A is fixed, no displacement, B is fixed, no displacement. So the structure is statically indeterminate, but kinematically determinate. So that's about the size of, so the size of the flexibility, so as far as indeterminate structures are concerned, the size of the flexibility matrix will be decided by the degree of static indeterminacy, which is necessary for flexibility method. The size of the stiffness matrix will be decided by the degree of kinematic indeterminacy, which is essential in the case of matrix stiffness method. So when the structure is statically indeterminate 2 degrees, kinematically indeterminate 2 degrees means you can follow any method. Suppose the structure is statically indeterminate to 3 degrees and kinematically indeterminate only 2 degrees. So normally the kinematic indeterminacy is less, therefore the stiffness method will be preferred. So you have to find out the unknowns. Unknowns are the displacements here. From the displacements, ultimately we are going to find out only the final forces. So how to do those things? So what are the basics that are necessary? Only if you are strong in your basics, the method will be convenient. Therefore, these are the basics. Then in the future classes, we will discuss about the step-by-step procedure for matrix flexibility method, step-by-step procedure for matrix stiffness method, and then we will take up the analysis of continuous beams, portal frames, and also the redundant trusses. So you are expected to recall your memory, expected to be strong in your basics. The method will not be difficult. You will have to systematically follow the steps. After doing some 2 or 3 problems, you have to repeat the same steps. Sometimes you will find it boring, but you have to do it. You have to do all types of problems. So with this introduction, let me stop the lecture with this. Next class we will take up the flexibility method and also how to derive or generate the flexibility matrices for determinate structures. So that's about the day. Thank you for your cooperation. Thank you.